For the overall experiment of Lab 1, I formed two pieces of charge tape, tape A and B, by quickly removing them from a base piece of tape. As shown in the figure here, I placed one charge tape on an elevated surface and observed its interactions with the other charge tape. The system I assigned for the lab was tape B, the elevated charge tape, and I used this system to solve for the unknown quantities listed here. While I was conducting the experiment, some goals that I was trying to achieve were observing the interactions that two pieces of charged tape have with each other, as well as analyzing how positive, negative, and neutral charges on certain surfaces generate electric fields. However, in order to make the experiment understandable, I had to make some assumptions, such as modeling the charge as a single-point charge, recognizing that the net charge of the system must not change, and that the charge is evenly distributed across the length of the entire tape, as well as ignoring air resistance in the y direction. To guide my experiment, I employed some useful fundamental principles to verify my findings. Primarily, I used the free body diagram shown here to assume that the net force in the y direction must equal 0 because the momentum of tape B must equal 0, according to the momentum principle. The only forces acting on tape B are its gravitational force as well as the electric force from tape A, which I found using Coulomb's law, listed here. I observed that tape A and tape B repel each other, so they must have the same charge. Also, they attracted to a negatively charged pencil, therefore signifying that tape A and tape B are positively charged. As a result, tape A and B would repel positively charged objects and attract negatively charged and neutral objects. Using the data listed here, I calculated the unknown quantities previously mentioned to support my findings. The gravitational force on tape B is 0.001962 newtons. Since the gravitational force equals the electric force, I was able to find that the charge on tape B is 4.67 times 10 to the negative 9. And using the formula, the charge of QB over E, with E equaling 1.6 times 10 to the negative 19, I found that the number of electrons present on tape B is 2.92 times 10 to the 10. To find the number of atoms on tape B, I divided the area of tape B by the area of an atom to get 1.27 times 10 to the 17th atoms. And the ratio of electrons to atoms is 2.29 times 10 to the negative 7, indicating a loss of electrons as the tape became positively charged. My code in GlowScript supports my analytical calculations because I modeled both tape A and tape B as single-point particles, and I used the gravitational force, Coulomb's law, and the momentum principle to show that the net force in the y direction is 0. This model supports my findings by showing the gravitational force arrow, the electric force arrow, and the relative distance between A and B. And these are my findings listed here below the model. What if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and the other charged objects? Well, if electrons had positive charge, then the loss of electrons from a particle would result in a negatively charged particle rather than a positively charged particle. Therefore, the charged tapes would be negatively charged, but they would still interact in the same way as described in my observations above, but in the opposite way. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? The transfer of electrons from our hands or other objects to the tapes will occur at a more rapid rate because of the positive charge of the tapes. Therefore, in order for the charged tapes to remain positively charged for longer, there should be the least amount of handling as possible to prevent the tapes from becoming neutral. In conclusion, I was able to use the fundamental principles, such as Coulomb's law and the momentum principle, to determine and quantify the interactions between two positively charged pieces of tape. Thank you.